The tectonic plate under the Pacific Ocean is being torn apart, scientists reveal. While it's the reigning theory now, the road to acceptance was long the bumpy for plate tectonics, which describes how large portions of Earth's crust slide, grind, rise, and sink ever so slowly across its sluggish mantle. But even now, more than half a century after it was given the scientific tick of approval, the theory needs some refining. A new study looking at 4 plateaus in the western Pacific Ocean suggests that these expansive areas are not rigid slabs, but they are weak spots being yanked apart by distant forces at the plate's edge. The theory is not carved in stone, and we're still finding new things, says University of Toronto geophysicist Russell Pisquilwick, who co-authored the study. We knew that geological deformations like faults happen on the continental plate interiors, far from plate boundaries, but we didn't know the same thing was happening to ocean plates, adds first author Eric Gunn, also an earth scientist at the University of Toronto. For decades, scientists have been rewriting their understanding of the seafloor, so this new study is just a continuing of their efforts to chart the ocean's rugged topography. In the 1950s, ocean cartographer Marie Tharp's pioneering work to map large parts of the seafloor using sonar data from warships showed that the ocean basins were not at all flat surfaces as scientists had suspected. Rather, the seafloor was carved up by gaping trenches and massive mountains, none larger than the Mid-Atlantic Ridge, which Tharp discovered and is now recognized as the longest mountain range on the planet, slicing the Atlantic Ocean into two. Such mountain ranges form when 2 tectonic plates collide and Earth crust buckles, or one plate dips under the other, thrusting the overtopping plate upwards. Underwater, though, the submarine mountains usually form as 2 plates, drift apart at the so-called divergent boundary, and magma spews out. But far away from these plates' boundaries in the center of oceanic plates, scientists thought that large sections of Earth's crust remained fairly rigid as they drifted atop the mantle and did not deform like plate edges. To test this thinking, Gunn, Pisquilwick, and colleagues gathered existing data on 2 ocean plateaus that lie between Japan and Hawaii, called the Shatsky Rise and Hess Rise, the Ontong Java Plateau north of the Solomon Islands, and the Manihiki Plateau to the northeast of Fiji and Tonga. Given the challenges in surveying the seafloor, their study was limited to these 4 plateaus in the western Pacific Ocean for which data were available. The oceanic plateaus are located hundreds of thousands of kilometers from the nearest plate boundary, yet Gunn and colleagues found the plateaus shared deformation and magnetic features that suggest that they're being torn apart by pull forces at the Pacific plate's edge, where slabs are being subducted underneath neighboring plates. The ruptures or fault lines identified by the researchers tend to run parallel to the closest trench, as you can see in the maps we have there. The team also modeled tectonic plates dynamics for 4 hypothetical plateaus located between 750 and 1,500 kilometers, that's 466 to 932 miles from the nearest subduction zones, to get a better understanding of the mechanisms giving rise to the distant deformations. Regardless of their distance from the plate edge, these hypothetical plateaus were stretching over millions of years and thinning more on one side closest to the trench. It was thought that because the sub-oceanic plateaus are thicker, they should be stronger, Gunn says, but our models and seismic data show it's actually the opposite. The plateaus are weaker. Acknowledging the only analyzed 4 plateaus of the Pacific, the researchers hope their findings spur further exploration to map the seafloor. Sending research vessels to collect data is a major effort, Gunn says. So in fact, we're hoping our paper brings some attention to the plateaus and more data will be collected. The study was published in Geophysical Research Letters. This by Claire Watson on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.